find a prime. We didn't do the red yesterday.
We did.
Derivative. Okay. So we do have to do. We first. 10x. Multiply the left hand fraction by x to the third on top and bottom, and we got 10x minus 10 over 3x.
So if we left it like something else, it would be okay.
It would be difficult to find when it equals 0 though. And so since we need to know when it equals 0 when it's undefined, that's why we went all the way there. And so when does it equal 0 and when is it undefined?
0, 1.
Undefined at 0 equals 0 at 1. I'm going to do a sign chart. Plug in -1, so I get a negative on top and a negative on bottom, which is positive. Plug in a half. I get negative on top but positive on bottom. And if I plug in 2, I get positive over positive. Positive. So I'm increasing from negative infinity to 0, 1 to infinity, and I am decreasing from 0 to 1. Do I have any relative extrema? What do I have? At 0, I have a relative max. That point would be the point 0, 0. How did I do that so fast?
There's 0 and then you plug in 0 on the y.
I plug in 0 to find the y, and I've already done that for the y-intercept, so I kind of already knew it was at 0, 0. And the relative min is at 1, negative 3. Is that right? How am I getting that? Plug 1 in. 2 times 1 is 2. 2 minus 5 is negative 3. Negative 3 times 1 is still negative 3. Second derivative information. I would go back up to the unsimplified form of the derivative. Do you know what I mean? Before I add a common denominator. If I leave it this way, I have to do a quotient rule. I would rather not. So I'm going to go back up to 10, there's x to the 2/3 minus 10, there's x to the negative 1/3, and take that derivative. And so I get 20 ninths x to the negative 1/3 plus 10 ninths x to the negative 4/3. So I get 20 over 9x to the 1/3.
That's like what?
10 over 9x to the 4/3. No one on the left needs an x. Does everyone agree? X to the 3/3 would add to give you that 4/3. If it doesn't shut off, it's coming. So I get 20x plus 10 over 9x to the 4/3. So set the top equal to 0 and the bottom equal to 0. Negative a half and 0. Plug in negative 1. Now we get a negative. Would you agree the bottom's always positive? Just one more. Let it circulate. The bottom's numerator would be odd. Well, really, they both have to be odd because if the denominator was even, then it would be undefined. So the negative is the bottom place.
If you have a square root or something.
So I feel like the first derivative is x to the 1/3 on the bottom.
Right. So it's instead of a cube root.
So you can have cube roots.
Okay, so if I plug in -1, I get negative on top, positive on the bottom. So that's negative. If I plug in -1/4, I get a positive over a positive. And then if I plug in anything above 0, I also get a positive. So I am concave down from -infinity to -1/2. And I'm concave up. The AP exam will take this answer two ways. They'll take it from -1/2 to infinity. It will also take it if you break it up because it's 0. So they will take that answer either way. If it were multiple choice, it would only be one of those as much. Points of inflection. Is there a point of inflection? Is there a point of inflection? Yes. Are there 2 points of inflection? No. Why not?
Oh, the 0 is 1 and 1.
Right, it has to change signs. Remember, the second derivative has to change signs. So the only point of inflection is at -1/2. If I ask you points of inflection on a test, is it very likely that I will throw in a fake?
Yes.
Very likely. So check that. So the points of inflection are -1/2. If I want the y value, I go all the way back up to the top. -1, -6. Cube root of 1/4. Someone tell me that value decimal value.
What's inflection?
The second derivative is 0 or undefined and changes signs. Any questions so far? Now that
Oh, wait, no, that was just the decimal you wanted. I don't know what it was. -1. That was just the x to the cube.
then you multiply by -6.
-3.779.
You don't know where he's getting that value? The original. It's a really nasty fraction with it. Decimal value. Now I'm going to graph all of this information. I'm going to plot everything I have. So in fact, if you read the question, it's a sketch a complete graph of this option. So we're going to sketch everything we know. From the original, we know the x-intercept is 0 and was it?
It's 5 root 2.
We know the end behavior. Use that later. We know we have a relative maximum here, so we're going to curve down like that, right? And we have a relative minimum at 1, -3. I know that I am, so somewhere in there I'm going to have to change direct. Where am I changing concavity at? -1/2. So I am concave up from, this is concave up, isn't it? So that one's going to look weird, isn't it? makes sense. What's the derivative at 0? What was the derivative at 0? What was undefined? So does it make sense that I have this weird sharp corner there with two concaves up? So at first glance, I thought that was a mistake, but if I look closely, it makes sense. That undefined derivative. Okay. I am increasing from negative infinity to 0. Up here, I'm increasing all the way to 0. I am increasing from 1 to infinity. And I'm decreasing from 0 to 1. Do I have the concavities right? I think it looks good there. So now I kind of wonder, how did I do? Pick up a calculator, graph that for me. Again, you told me yesterday this wasn't possible to graph, right? I cannot graph that by hand. We sure don't want to very often. But we do.
Pretty good.
Pretty good? Looks pretty good, doesn't it? Pretty impressive. Again, we hope to do that often, but we learned what we now know from all three parts. If I had not known any of the information, would my graph have been less accurate? Yeah, the concavity helps me out at that weird point. This is the most typical type of second derivative test question that comes up. And it's the answer to implicit. Sometimes you have to do the implicit. They've already done the implicit differentiation for us here. So this is part of an AP problem that I've pulled here. It's a good problem for you to see where the second derivative test comes into play in AP. So, suppose y of f(x) is a function such that f of x is differentiable at x equals 0. F of 0 is 0, f of 1 is negative 1, f prime of 0 is 0, and the derivative of f dy dx is 3y squared plus x divided by y squared plus 2. So you can tell this looks like an answer to an implicit differentiation problem. Part A is just a tangent line problem. We've done a million of those, but let's see if we still know how to do that. Let's see if you can find the equation for the tangent line at 1. For part A, are there some distractors in there? So be careful, use the correct information. So what do you need for a tangent line? X, y, and slope. I have an x, they gave me an x. Did they give me a y? It's this one, right? Y plus 1. How am I going to find the m? Because they did not give me the m. Plug in 1, negative 1 into the derivative for x and y. On your work, if this is a real AP problem, show this. dy dx at 1, negative 1 is, so the the AP, so you can get the point even if you miss the tangent line. Show them that you're doing the derivative at 1, -1. And so our point at -1, so we have 3 times 1 squared. Plus 1 over -1 squared plus 2, which is 4 over 3. Any questions about that? So that's kind of an old hat problem. We've done that before. The new stuff is, does f of x have a maximum, minimum, or neither at 0 justified? Do I know a point to the left of 0? An x and a y value to the left of 0? Do I know one to the right of 0? I don't, do I? I don't have an xy combination to the right of 0. So I'm not going to be able to use the first derivative test. Does everyone see why? Because I don't have enough information to do a sign chart. So I'm going to have to use the second derivative test, which means I need the, I have the first derivative, means I need the second derivative. So I have to find the derivative, which we've done before, haven't we? Low d high minus high d low over low squared. I got low d high minus high d low all over low squared. It looks like this is going to be a difficult problem, but it turns out because of the number values, it works out nicely. I want to know the second derivative at 0, 0, right? So the second derivative at 0, 0, I'm going to plug in 0, 0 in for every x and y. What am I going to plug in for dy dx? I could. Why 0? F prime of 0, 0. So isn't dy dx at 0, 0 also 0? So I can just plug in 0.
So how'd you know that? That's what you needed to plug in. You know the x is at 0, but the y, did you just...
So this tells me x and y are both 0, and this tells me that dy dx is 0.
So if it was with any other number, did you do that too?
Yes. Now, I could do what you said and it would work out.
It'd just be gross.
Like, yeah, you'd get 0 over 2 anyway, which would be 0. So you'd get there. It's just saves you some time. So I get 0 plus 2, which is 2, times 1. Everyone agree? Minus 0 over 2 squared.
So shoot dy dx gives you W.
And you see why? Since f prime of 0 is 0. So they didn't have to tell you that. They could have made you find that. They were trying to save you time. If you could have plugged in 0, 0 into dy dx and found that it equals 0. But they just saved you time. 2 over 4, which is a half. What is the only thing I really need to know about that, though? It's positive, which means I am concave up, which means 0, 0 is a relative minimum. It's table problem the other ones where they just only give you enough information to use this. That's all I have. You have your homework already. Work. You have 5 minutes. Half the work.